Hello all, welcome to Code Hub. Today let us solve the lead codes daily challenge, and today's problem is increasing triplet subsequence. What is the problem states? Given an integer array nums, we are given an integer array. We have to return true if there exists a triplet of indices I, j, k such that I is less than j is less than k, and also nums of I is less than nums of j is less than nums of k. So nums of k. So like this we have to find whether it exists, or else we have to return false. So we are given an array 1 2 3 4 5. Let us consider this example one. There exists a triplet of indices where we can consider 1 3 and 5. As you can see, 1 is less than 3 and 3 is less than 5. And if we take 2 3 4, 2 is less than 3 and 3 is less than 4. So there exists one such triplet, so we are written true. So we can take the second example, 5 4 3 2 1. Here there is no triple elements, that is satisfying the condition, so we return here false. And let us try for the example 3. Example 3 is 2 1 5 0 4 6, and if we take the elements 2 5 6, the condition satisfies, and we can take 1 5 6, or we can take 1 4 6, or we can take 0 4 6. There are many possible ways to make the triple elements that satisfies the condition, so we return true here. So this is what the problem. So what we can do is we can try a brute force manner, and we can take all the three elements that in each for loop, and it may become an order of n cube solution. But how can we optimize this? Okay, we can use an extra space and keep track of the minimum elements to its left and the maximum elements to its right. Once we have the elements, we can just check whether there is any element that is whether there is any elements that satisfies the condition. So how can we check? We can take the example 1 2 3 4 5. I will first build an element, minimum element, from its left side, that is till the for the first element there is no minimum element, so let me consider it as -1. And from the second element the minimum element is 1 to its left. And then for the third index the minimum element is also 1, and for the fourth also 1, and fifth also 1. And similarly for the last element there is no maximum element, so we can make it as -1. And the last before index 4 there is any maximum element till now that is nothing but 5. So the 5 is the maximum element till now to its right, and here also 5, and again it is a 5, and again it is a 5 to its right. So at this particular index the maximum element to its right is 5. So what does this mean? If we are having the minimum element from left to right and the maximum element from right to left, we can traverse the index from second to last before index, and check whether there is an element that is smaller and there is an element that is larger. That is as you can see, the for element 2 the smallest element that is before 2 is 1, and the largest element that is after 2 is 5, and it satisfies the condition. Let us take for the index for the third index the element is 4 at the middle, and the element which is at the previous is 1, and at last that is to its right side is 5. So this also satisfies the condition. So by using an extra space we can say we can check this condition in order of 1, and for the time complexity for this solution will be, obviously, let us say this as approach 1. The time complexity for the solution will be order of n, and the space complexity for the solution will be order of 2n. There will be in 2 extra space 2 into n array, but anyway we can generalize and say it as order of n extra space. So let us try to code this approach and then we can go for optimization if there is any. And first we can declare a size left to right is minimum element from left. That is what this array of size n, and I will mark it as -1. And the maximum element from right, max from right, and this also size n minus 1. And I will take the size of the array is nothing but num star size. And what we are going to do is from int I equal to 0, sorry, I starts from index 1 till n I plus plus, int minimum element is nothing but the nums of I. So minimum element is nothing but first I will assign the min from left is nothing but my minimum element, and minimum element will be updated to min comma nums of I. The same thing we are just copy pasting and calculating the maximum to from its right, max nums of n minus 1, and this should come in opposite manner. So in I equal to n minus 1, n minus 2, I greater than or equal to 0, I minus minus, and this is nothing but max from right of I. Sorry, here we have to give the index. Max from right of I is nothing but my max, and I will update my max to be max comma nums of I. And once we have built this array, we are going to run a for loop from int I equals to 1 till I is less than n minus 1 I plus plus, and I'm going to check for this condition. What condition? They have given that nums of I should be less than nums of j plus should be less than nums of k. So what does that denote? My min from left of I is less than my current element nums of I, and my current element nums of I should be less than my max from right of I. If this is true, I will return true. Finally, at the end of the day, if I couldn't satisfy the condition, I will return false. So hope this makes clear what is the approach I'm doing here. I'm using an extra space. Nothing. Okay, it is nums of 0. Yeah, now it should work. Yeah, it gets accepted. Let us submit the code. Superb, it got accepted. Hope you like the solution, but this is not an optimal solution because there is a follow-up for this problem. What is the follow-up? If we have to say whether we can implement this solution in order of n time complexity and order of 1 space complexity. We can build this optimal approach using the approach that we have built now. It is nothing but approach 2 we are expected to do in order of n time and order of 1 space. How can we eliminate this space? What you can see that this two vectors are just updating the minimum element that is from left and the maximum element that is from right. So on the go while we are going and traversing the array, if we can keep track of the first smallest and the second smallest, if we can keep the track of this first smallest and second smallest, then what will be our case here? The case is nothing but if my first smallest is lesser than my second smallest, and if my second smallest is lesser than the current element is nothing but the nums of I. If I can do this way, I can reduce the extra space. That's what they are coming to say. So I want to make the space complexity to be order of 1. So how can we do this? Let us see how I am coming up with that approach. So if I can change this condition to be like this, then it will be we are eliminating the extra space. But how can we do this? First, let us try to have two variables, the first smallest and the second smallest. First smallest to be initially int max. I am keeping track of the minimum element, so I will be initializing it with bigger value initially, int max. So what I am going to do is I am going to keep track of the first smallest and the second smallest. What I am going to say is, if my current x is lesser than or equal to my first smallest, what I am going to say is my first smallest is nothing but first smallest is nothing but x. And if this is not true, else if my current x is lesser than or equal to second. So if my current x element is lesser than or equal to second smallest, then my second smallest will become my x. And by this two if conditions, what I am denoting is I am keeping track of the first smallest, that is left most, and the second smallest, which is between the leftmost, between the first smallest and the current x. So if I can keep the track of this first smallest and second smallest, I can check this condition. If this condition is true, then obviously I can return true, else I cannot return true at all. So let us try to trace this approach in example 3 so that it will be clear. So the example 3, the test case is 2, 1, 5, 0, 4 and 6. Consider this is the array, and I initially my first is int max. And my second is also int max. And what does this mean? If my current element 2 is lesser than my first, yes, it is lesser than my first. So what my first will be get initialized, the first becomes my 2 becomes my first smallest. So the else if condition will not be executed. Next I will go to this element. Now I will check whether first is lesser than or equal to 2. Yes, it is lesser than or equal to 2. So first now my first becomes as 1. And I'm going to the next element. Now as you can, why this second is not getting executed, because there is no element that is smaller than 1 to its left side. So now the second element is not yet updated. So now I'm coming here, 5 is lesser than or equal to 1. No, it is not. So it will go to into the else if, and 5 lesser than or equal to int max. Yes, it is. So 5 is updated in second variable. Then you will be checking whether 0 is lesser than or equal to 1. Yes, it is. And I will be checking this if condition before every time, because the current element should be lesser than the current element should be greater than this 5. Yeah, still it is not. So what I will do is the 0, the first now the first element becomes 0, and else if part is not executed. And in the next iteration, you can see that 4 is 0 is lesser than 5, but 5 is not lesser than 4. So what happens again, it comes to this if else if conditions, and it gets updated. Since 4 is not lesser than 0, it will not update first, but it will update the second. Since 4 is lesser than 5, so it gets updated to 4. And now the current element 6 is greater than 4 and 4 is greater than 0. As you can see that I have this satisfied the condition which we needed. So we return true. So what does this do is we are keeping track of this first smallest and second smallest on the go. So I will initialize the first smallest, which is initially int max, and similarly the second smallest, which is also initially int max. And on the go I am checking for this condition, but you have to see that I have picked two elements. So for that case we can check whether this second smallest is not equal to int max only. I will check for the condition, or else I will not check for this condition. If my second smallest is not int max, then I know that second smallest there is some value which is inside the array. So I will check this first smallest is lesser than second smallest, and the second smallest will be lesser than nums of I. It will be true. So nums of I starts from 0 and it will go till n. And once this if condition is not executed, then I will be updating my first and second smallest. If my nums of I is lesser than or equal to first smallest, then my first smallest becomes my nums of I. Else if my nums of I is lesser than or equal to second smallest, then my second smallest is nothing but my nums of I. I have updated this, so finally I will be returning false if I am not satisfying the condition in the array. So it gets executed successfully. Let us try to submit our code. Superb, it got accepted. This is nothing but the optimal solution that they are expecting. So order of n time and order of 1 space. Hope you like the solution and let me know in the comments. And if there are any suggestions, put in the comments. So let us see in tomorrow's Lead Code Daily Challenge. Until then, bye.